I think we can start. So today I want you to do this. So this side, I'll show what you can do on this side. See here, now you have a few resistors with you. Yes or no? You have a few resistors. So yesterday what we did is, this is a better side than the other one, where you can enter the value of the, see, suppose if I say 10k, you can type in 10,000, okay? 10k means you have to type 10,000. When you type 10,000, it will show you what is the color that is required, and from that you can pick the resistor that you have. So I said yesterday we were using 330 ohms. Alright, yesterday we were using 330 ohms. For 330 ohms it was orange and brown. Is it changing in the video? The video it's not changing, I guess. You can try this side, see if it's working for you. For it, in the video it's not changing. The colors change dynamically. 100 ohm, 107. 1007 when I type there's nothing coming. Why? Any idea why nothing is coming when I'm typing 1007 value? We don't have a resistance. We don't have a resistance with 1007 value. Okay. That is why it is showing like this. You see the image? If there's an available resistance value, it will show. Suppose I type 113. The value, that value of resistance is not available. So what I can do is, I have to use a potentiometer then. If I want 113 ohms, I have to use a potentiometer. If it's 110, I will have a potential, I will have a resistance, so I can use that resistance. Similarly, in the side, suppose you have some resistor. So I have a resistor over here, which is having yellow, purple and red. Again, this is what I had yesterday also. Okay, I'll take another one. So this is having brown, green and brown. So brown, green and brown. So this is 150 ohm resistor. So from the color code also I can able to find what is the resistance value. Again, from resistance value also I can able to find what is the color code. So that is why this side I am giving you. See here. So we'll do this circuit. We'll do this circuit both in simulation and in real time. Okay. So for simulation, which I will explain, just listen. So this is the battery source. Okay, this is the battery source, and the LED, as we know, the LED needs to connect along with the resistance. So we have resistance before the LED, and in between that we have a switch. Switch can be placed anywhere in the circuit, either here. Switch can be placed in any of these locations, no issues. So here we are having the switch over here, and why it is represented like this is because it's a push button switch that we are using, but we will be using a normal switch only. We'll just on and off. Okay, we'll turn it on and off. So there's a switch which is connected to a LED, and this is your capacitor. And from the capacitor we connect to a, so that it does not drain off instantaneously, and then it goes back to the battery. Suppose if this line is not there, suppose imagine I have not connected over here, I just kept this resistance floating, then what will happen is nothing will happen because the circuit is not. So whenever we make a circuit, we have to make sure it is actually starting from a positive, it goes via the components and reaches back to the negative of the battery or the power supply. So wherever you can be parallel, serial, what yesterday we saw, right? See, yesterday in this circuit, you can see it starts from the battery, goes through many circuits, like many parallel lines, and again everything combined goes back to the battery. Okay, every line has to be connected and has to go back to the battery. Then only it is a closed circuit. If something is not touching or not going back to this line, the operation will not happen properly. So here it's a very simple circuit, resistance, LED, and we have a switch in between. So a capacitor which can store the energy for a short duration, and then the what we call another resistor just to hold the capacitance for few duration, small duration, and then drain it off to the negative side. So this is what you will get when you are opening that link, Tinkercad. So you have to log in. You have to create a login, sign up. So student, as a student, you can create a student. Since all of you are students, you can create students. I have created a login and I have logged in. When you're logging in, probably for you it might be different or same also. You're logged in like this. I should select circuits. Okay, so I should select circuits and okay, Tinker circuits. From Tinker you have to, from here you have to select circuits. So it goes to this particular location where I'll click start tinkering and I'll create my first circuit here. So a new window will open. So if you see this window, everything is empty. Everything is empty, and we have all the basic components here. We have the breadboard here. Okay, that's the breadboard. You want a battery, 9-volt battery, that is available. Suppose you want a 1-volt battery, that is also available. You want a motor, that is also available. Transistors, STVs or transistors, there it is. So LEDs, this is RGB LED, normal LED. Here resistance, capacitance. So everything is available. So whatever we want, we can select and we can do it. Okay. Switches again. So whatever we want, we can actually select and use it. I'm making it a bit small, so by clicking and pressing the delete key, you can delete the unwanted components. So from here, I'll take this. I require a LED for the circuit. I require a LED. What else I require? You've drawn, right? What are the components I require? Tell me the components I require. I want a LED, then I want a battery. The battery is connected like this. Just click on the, it will be like very easy. Click on the terminal, drag and click. Click on the terminal, drag and click. And if you want a LED, just click on it, move your cursor, and wherever you want, you come and place the, and it will show which is the anode and which is it will show which is anode and which is cathode. Okay. Suppose you want anode to be on the other side like this. So you go on top over here, you can see over here there is a symbol, mirror component. Click on that, automatically the anode position will change. Okay. So I get one LED, I require a capacitor. Capacitor also I keep like this. And it's in nanofarad. I'm going to change it to farad so that we can see the blinking. Then I need a resistor. So from resistor is what? I'll have the switch. So from resistor I have the switch, and from the switch I have the LED. So LED is anode is connected. So I'll flip like this. I'll place my anode in the same line over here. You can see that. So from the, sorry, this should be in the positive. Okay. So from the positive terminal of the battery, I'm connecting the resistor to the push button and then to the LED, and from the LED I'll have it to the capacitance. So on the same line of the LED I'm placing my capacitance, one side of the capacitance. Then again another resistor, and so resistor it's vertical. When you want horizontal, you can just simply click on this icon that is the toolbar. On top you can see as I click it rotates. So when it rotates, I just need to move and place it on the same line of as of the capacitance. Then I need to connect my negative to the resistor. Okay, so I may not go and pinch on the wire like this. On these terminals, if I like all these holes, if I place it, there's a connection established. You can see there's a connection established. So you see there's a line that pops up when I put my cursor at the bottom. So meaning there's a connection internally. So that's my circuit. So this circuit can be drawn in a different manners also. It's all your idea. Then I push the start button. You can see this light goes off slowly. You see the LED glowing off slowly. I'll just show a demo. They will not do also. Just see this. Just the demo for you. We will do the other experiment. Today we are going to use an IC called triple. This IC is called as a timer. Its function is to generate some time delay, which can be used for various applications like blinking of an LED, or to energize or to activate an LED for a short duration. Only for one instance it will activate and then it will go off. Okay, so this circuit is just for that one activation circuit. As you're doing, I'll just finish the circuit and I'll show the simulation also. So this LED will flash just for 1 second and it will go off. So for such kinds of application, we'll be using this particular timer. So the same timer IC we are using here in our circuit for touch sensor. The touch sensor is you should have seen, like whenever we touch the object, okay, whenever we touch an object, there's an indication that alerts us saying someone is touching an object or someone is touching our door or personal things. So we can use this particular circuit for such kind of application. Here we are not going to use any sensors. Okay. Here what we are going to use is like two pins, or what you call stapler pins. We will be using some two stapler pins which will act as a touch sensor. So whenever you touch that stapler pins, this LED will indicate us that there is a person who is touching our objects. So you can take a screenshot, or you can take a screenshot, or you can draw this drawing. You can take a screenshot of it, or you can use this to make your circuits. Okay, I'm not sure we can do it parallelly along with the circuit and the video. IC, if you're taking the 35 IC, raise your hand. To show that IC close to the lens. Let's see if the number is visible for them. Number is not visible. Okay, on top it will be written NE555. On top it will be written NE555. Then we need 2 LEDs and stapler pins. Get some 4 stapler pins. Get some 4 stapler pins. Okay. So like that you have to bring the stapler pins. So you need to connect one resistor which is connected to pin number 3. Do the connection like this. Pin number 3 is an okay. So pin number 3 you have to count pin 1, 2, 3, and the third pin you have to connect this resistor and put it on a breadboard. Connect it on the breadboard as shown. I'll cutting the camera. So 330 ohms. You have to take a 330 ohm resistor. Color is orange and black. Orange and sorry, not black, brown. Then we'll take LED. Okay. Then we'll take an LED. So LED, the longer cable, the longer feet you have to select. So that is longer feet is what? Anode or cathode? The anode, connect the anode to the resistance. Connect the anode to the resistance. Connect the anode to the resistance. And the other side you place it on the breadboard. So you can see cells connecting, like one end is connected to the resistance and other end is connected to location. You can directly keep it where the power supply is. Supply ground. You can the other location you can connect it to the power location ground. Yesterday you practice the positive and negative of the line, right? So you use the same concept. Resistance to the LED to the ground. Finish the connections, LED to ground. Now we'll place the pins. Place அப்பதான் LED வரலாம். அந்த LED வரலாம். So pin is connected between pin number. You can see cells connecting 2 pins. Can you see that? So at pin number 1 we are having a pin, and pin number 2 we are having a pin, like that. From the stapler you took a pin, right? So that you've done this stapler pins like that as shows. So on the other side also we need to connect pin number 7 and 8 also we have to have this pins. Pin number 7 and 8 also we have this pins. Pin 7 and 8 also connection பண்றேன் 7 8 ல. Pin number 7 and 8 also we have the stapler pins connected. Pin number 7 and 8 also the stapler pin is connected. 8 and 7. 8 and 6. Okay, 8 and 6. Pin number 8 and 6. Sorry, not 7, 6. Okay. So now what was one more component we have to connect? What is that component? Other than battery, one more thing.
Switch.
Battery is power supply. We don't require switch for this. Our touch. So these pins are going to be the switch for the circuit. Our sensor. That is the sensor is going to be the switch. LED. If you had seen this diagram, purposefully I said not to connect the LED to Ranjit. Just wanted to get information from you. So one more LED we require. So that is connected to pin number. You can take a screenshot.
Pin number
3. Yes, correct. Pin number
3.
Pin number 3 is cathode or anode? Yes, cathode. Pin number 3 is cathode. Okay. At pin number 3, you have to insert the cathode of the LED. Pin number 3, cathode of the LED. LED is connected to the power supply. So the other end you can connect it to the power supply. The anode you can connect it to the power supply. Plus positive of the power supply. As sir is showing, is connected to the positive line. Is connected to the positive line. And the pins also you can see one pin from pin number 2 it is connected to positive, and from pin number 1 the pin is connected to the ground. From pin number 1 the stapler pin is connected to the ground, and from the pin number 2 if you show like that we can't see. Show it like this. Show it like this as showing. Like this you have to show. that's it. You see it's changing. And the pin number pin 1 to ground.
Ground.
1 to ground, then 2 to supply. Here it is.
No sir, no sir, no ground sir.
Oh, no ground. Just
Only plug in. Just
one plugged in. Okay, that's not grounded, just plugged in. Two pins. Put it in the term. Other side you can remove. Now you have to give the power supply to the IC power supply we are missing. You show your circuit.